Great.
I need more time.
Huh? Say again?
No.
What?
But I need more time to express.
Too much time. You had too much time. Okay, write this down. It is an easy lesson. Very short.
Is the homework easy?
Of course! Always easy.
No.
Ah, yes.
Like yesterday.
Ah, yes.
Liar.
No, I'm not a liar. I'm a teacher.
Oh, liar for homework. And yes.
What, shishay? Ready? Yes. So, have you got that written down?
No.
Oh, Amanda. Grace, please put the phone away. Right. Okay. Can you try your best to draw this, please? Beautifully. Beautifully. Oh, ugly. Beautiful. Plus, plus, plus. Plus hash brown.
No. What hash?
It looks like a hash brown. It's a triangle. Did you draw this?
It's a ladder in the wall.
It sure is. It's a ladder against the wall. And what I want you to notice is that there are three forces on the ladder. Can you see that? The first force is between the ladder and the wall.
No.
The second force is the weight
It's weight like.
in the middle of the ladder.
Yeah, maybe when if someone is up there.
There's no one on it right now, but the weight of the ladder,
Okay,
the ladder itself, yeah.
Okay.
And the last force is the reaction between the ladder and the ground. What you'll notice is that these three forces, if you draw lines from them, they all meet at the same point. Do you see that? Now, you might be thinking, did they have to do that? For example, could it not have been like this? weight here, reaction here, you know, reaction here. So if you draw the lines like this, see, they don't meet together. And you might be thinking, so should they always meet? So let's see. So imagine we have a shape, and it's not moving, it's not rotating, and there are three forces on it. So I'll call this one here a force here, F1, F2, I don't know, F3, or F, sorry, the other way, F3, like this, and it's not moving. Okay, because these are vectors, I guess. Hang on, yeah, let me draw that nicer. Sorry. We'll put one here, one here, and I don't know, one here. Right, so what I'll do, I'll make, what will I do? Let me think. Let me think. No, I forgot actually.
So
You don't
which
know what
line
else?
meets together?
Yeah, but I want to prove that they always meet.
No.
Well, that's because I drew it badly. You know what? I forgot the proof. The proof. But that's okay. You can believe me that they always meet. Okay?
Just remember.
Yes. I'm sorry, I forgot the proof. So, anyway,
Watch Moodle.
I need to watch my video from last time. I forgot how to prove it. But you can trust me that they always meet when there's three forces. Okay?
When it's not moving, then.
When it's not moving,
Yeah.
the three forces, they always meet. It's special because, so what do you need? You need three forces, and it's in equilibrium. That means it's not moving, okay? So I think it's important maybe to make note of these 2 points.
Basically, these three forces are concurrent.
That's the word, yep. Got it? Yeah? Sure. Yes. Okay, got that? Yeah. When three forces act in the same plane on the mass in equilibrium, then all lines of action meet at one common point. So that's the theorem. And it's called the three-force theorem. Or, as you said, concurrent forces. But we just deal with usually three. So can you write this definition down? Or, well, this theorem. Theorem. Do you know this word?
No.
Ah, you do, like Pythagoras theorem. You know Pythagoras?
Yeah, I imagine.
You met him, yeah? He's a good fella, is he?
The line of forces meet or actually the forces meet about
A
it?
line.
Technically.
If you were to draw a line through them.
Not for the forces themselves.
No, not really. But kind of, but not really. Yeah? Continue? Let's see the proof. Let's not, I forgot it. Okay. I'll prove it for you next time if I remember.
Oh, no, no.
You remember the proof?
No, I know. No, later. Nothing about proof.
Right, so let's do our example. And good news, I said it's small. There's only one question to do. And then your homework is on these four. So write, yeah, I know, amazing, huh? So write this question down, please. Yes? Yeah? Did you write this down? Yeah? So let's have a look at this. A 10 kilogram ball of radius 5 is hanging on the wall with an 8 centimeter string. So what you've got here, here is your ball, and it's hanging on the wall, and there's a string here, and it's 8 centimeters, so that's 0.08 meters, and the radius here is 0.05, so this distance here is also 0.05, yeah. Yes. Yes. So, how many forces are here?
One,
Well, yeah, firstly, well, there must be the 3 because that's what we're doing. So, firstly, there's the weight. What did I say the mass was?
10 kg.
So, this is a 10G. And then there's a reaction force between the wall and the ball. So, we'll call this here R. And we know from the theorem that the force here must go through the centre. They all must meet. Now you might think, well, that's obvious. Well, no, it's not obvious, because maybe you thought it could have been, maybe it could have been like this. The weight goes down here, the reaction goes across here, and the force goes across here. Like, it's not obvious. But we know from the theorem that this force must go through the centre, because they all must meet somewhere. So if these two forces meet at the centre, then this one must meet at the centre as well. Okay, so you all have the idea? Yeah? No, yes.
the range force.
The reaction force.
Reaction force.
Yeah.
Can I say that it's like a graph?
Like this?
Yeah, just you give the example. They give the
Ah.
word give the force go on.
Yeah,
go
yeah.
from.
I should actually say, I don't think I said it in the question. Yeah, I should have said this is a smooth wall.
You did say.
Did I?
Yeah.
Yeah, smooth wall.
So smooth wall means it's like ice. There's no friction. That if you put your hand down, it will slip. So there's no up force here on a smooth wall. Yeah. Yep. Okay, so we know, we could know this angle here. If I draw the triangle, this is point 13. This is point 05. This triangle here. So the height must be, anybody? 0.12, very good. So I can get this angle here. Grace, how can I get this angle? Okay. How can I get this angle?
0.13 over 0.12.
Point tan inverse. Tan inverse 0.12 over 0.05.
Can I sign?
Yes, could you sign off it? Yeah. So you get 67.38. Yeah. Yeah. Okay. Grace, what's wrong? Grace, English, what's wrong?
5 times 13.
Yes.
Nothing.
Oh, everything's good.
Yeah.
Oh, great. Now, let me resolve the two forces here. So this one will be, can you see, it will be, I'll write it here, T cos theta, and how much will this one be? T sine theta. Now, what do I want to know? I want to know the tension. So I know that T sine theta should equal 10G. So I know that T will equal 10G over sine theta, because this force should equal this force. They should be equal. So I get T is 106.3 newtons. That's my answer. Yeah, it's not so bad, is it?
Yeah, it's not so bad.
Grace, what do you think?
Okay, but everything is in the same picture.
Yeah, I'm sorry, I'm messy. I'm a messy teacher.
No.
Got this?
Yeah.
Okay. Can I continue? Yeah. So, there's not much to this. I have some questions for you. Wait, listen. I am a tiny bit behind my schedule. You know what I mean? Oh, dudes, just listen for a moment. No, just take a picture in a moment. Just listen. I'm a tiny bit behind, just a tiny bit behind my schedule. So, next week, we'll have to try and do a little bit more. Okay? So, don't be shocked if I try to do 2 lessons in each class next week, in the 3 double classes. We normally have 3 doubles, don't we?
Yeah.
No? I thought it's normally double, double, double.
I don't know.
Isn't it? 3 doubles? Double, double, double?
Double?
It is, Monday is double
Monday
period,
double.
Tuesday is double period, and Thursday is also double period.
That's what I thought.
Yeah.
So, are we listening? I'm going to try and do 2 in each class next week. And then you have your holiday.
Happy holiday.
Happy holiday.
No homework.
Yes, much happy.
But there's an exam.
Very happy.